All right, so let's move on to the Chapter 4 notes, Part 2. So, a compound event is any event combining two or more simple events. So here's an example. Let's say you roll a normal six-sided die. Let A represent the event getting a 1, and B represent the event getting a 5. So I say calculate P of A or B. In other words, calculate the probability of A or B happening. In other words, calculate the probability of getting a 1 or getting a 5. All right, well, the probability of getting a 1 or a 5 will be 2/6. The reason is there are two ways for success, two desired outcomes. So there's two ways for success out of 6 total things that could happen. So 6 possible outcomes. So the probability here is 2/6, or you could change it to 1/3. Now I want to point out, well, the probability of getting a 1 is 1/6. The probability of getting a 5 is 1/6. And if you do the probability of 1, which is 1/6, plus the probability of getting a 5, which is 1/6, you get 2/6. So it seems like sometimes if we want the probability of something happening plus the probability of something else happening, it seems like sometimes we can just add the probabilities. All right, well, the problem is sometimes we can't. So, new example. Let's say that you have a deck of cards and you draw one card from the deck. Let A represent the event getting a queen and B represent the event getting a red card. Now calculate probability of A. So what's the probability of getting a queen? Well, there are 4 queens in 52 cards. So the probability of getting a queen is 4 out of 52, or 1/13. I'll leave it as that, though. Now, probability of B. What's the probability of getting a red card? Well, there are 26 red cards in the deck. There are 52 cards total. So the probability of getting a red card is 26 out of 52. 26 ways for success out of 52 total possible outcomes. Or in other words, the probability of getting a red card is 1/2. Now, I want to ask, well, what's the probability of A or B? Or in other words, what's the probability of getting a queen or a red card? So what we got to say is, well, how many ways could you get a queen or a red card? How many ways are there for success? Well, there are 26 red cards. So each of the 26 red cards is a success. It's a way to win, so to speak. Now, but those 26 red cards include 2 red queens. This covers the Queen of Hearts and the Queen of Diamonds. There are 2 queens left over. The 2 black queens, the Queen of Spades and the Queen of Clubs. So there are 28 winning cards out of 52 total cards. So the probability of getting a queen or a red card is 28 out of 52. Now notice that, so notice we can't do the following. Notice we cannot say the probability of A plus the probability of B gives us the probability of A or B. That doesn't work here. 4 out of 52 plus 26 out of 52 gives you 30 out of 52, and that's the wrong answer. The probability of getting a queen or a red card is not 30 out of 52. So sometimes we can just add probabilities if we want the probability of something happening or something else happening. Other times we can't. So why couldn't we add probabilities here? Well, if you add these probabilities, you're counting the overlap twice. So you're not taking into account when you do this that there were 2 red queens. It's like you got the 2 red queens covered in here, but you also got them covered in here. So you double counted the red queens is the problem. Okay. So, in the last example, events A and B could occur at the same time. It is possible to draw a card that is both red and a queen. In the first example, events A and B could not occur at the same time. It is not possible to roll a die once and have both a 5 and a 1 appear on the die. If you roll a die once, you can't have both a 1 and a 5. It's impossible. So these events are called disjoint, or also called mutually exclusive. Those 2 words are synonyms. So which means that the events can't both occur at once. So if 2 events are disjoint, or in other words mutually exclusive, they can't occur at the same time. Now if A and B are disjoint events, we see that the following is true. Probability of A or B equals the probability of A plus the probability of B. So if 2 events are disjoint, meaning they can't happen at the same time, we see we're in scenario 1, where with the die example, probability of getting a 1 plus the probability of getting a 5, it's 2, 6. That's the probability of getting a 1 or a 5. All right. Now, if A and B are not disjoint events, so it is possible for them to happen at the same time, it's usually best to find the probability of A or B by, now here's what I recommend. Here's what we did in the last example. We just figured out all the ways that A or B could happen. So if A or B are not disjoint events, meaning that they can happen at the same time, and you want to find the probability of A or B, I would recommend counting the number of ways A or B can occur and making sure that we don't count an event twice. After you've done that, divide that number by the total number of outcomes that are possible. That's what we did up here. We figured out the ways A or B could happen, the ways you could get a red card or a queen, and we made sure not to double count anything. Then we divided by the total possible outcomes. So that's what I recommend you do. I recommend you wouldn't follow some formula in the book. So you can if you want to, but anyway. So we saw before that if A is any event, then the probability of A happening or not happening equals 1. We said, well, that makes sense. Something either happens or it doesn't. The probability of me seeing a purple unicorn or not seeing a purple unicorn, that's 1. Either I'm going to see a purple unicorn or not. It covers all possible things that could happen. So the probability of me seeing one or not is 1, or 100%. So the probability of an event either happening or not happening must be 1. So A and A complement, or in other words, A and not A, are always disjoint because it's not possible for an event to both happen and not happen. So A and A complement, they're always disjoint, or A and not A, they're always disjoint events. Therefore, the probability of A happening or not A happening, it's always going to be equal to the probability of A plus the probability of not A, because they're disjoint. And that's always going to add up to 1. So we saw that in the last set of notes. The probability of something happening plus the probability of something not happening, it's got to add up to 1 because you've considered every possible scenario.